Alright, so our last video will talk about determining spontaneity of reactions using inert cell. We have two reactions here, A and B. We have Fe solid plus Mg2 plus aqueous to give us Fe2 plus aqueous and Mg solid. So that is our A. B is Fe solid plus Pb2 plus aqueous to give us Fe2 plus aqueous and Pb solid. Now we want to determine whether each of the redox reactions is spontaneous under standard conditions. So what you are looking for is answering the question, is each cell positive? So that's the question we are answering here. Is inert cell positive? Because we know spontaneous reactions have positive E cell. So that's what we are looking at. So if I take A, Fs plus Mg2 plus aqueous Fe2 plus aqueous plus Mg solid. So if I take Fe is losing electrons. So this is oxidation. And we know oxidation will happen at anode. While Mg is gaining electrons. So Mg is gaining electrons, and this is reduction. And reduction will happen at cathode. So when you get reactions like these ones, normally you go to tables. So just go online and say electrochemical series. So if you go online and say electrochemical series, you have a table that has what we call reduction potentials. So reduction potentials. So what it means is you are shown reduction half reactions. You can see that here we are reducing magnesium 2 plus to magnesium. We are reducing iron 2 plus to iron solid. We are reducing lead 2 plus to lead solid. So all these are reduction potentials. So you go to these reduction potentials and you can follow the normally they are written in alphabetical order. So here we start with F, Mg, and Pb. Here I have missed the alphabet here. So if you go to the tables, usually the tables will be given using alphabetical order. So if you look at the table, for question A, we have Fe. So in our table, this is our Fe. So this is our Fe from the table. And we know its voltage, which is negative 0.44 volts. And then we have Mg. Mg here. This table here has Mg. And here we are given the voltage. There should be a point here, 2.37. Here we are given voltage as negative 2.37 volts. That is the E cell of that half reaction. So we can say that the reduction reactions or the oxidation reaction, the E cell is because we are taking it from here, minus 0.44 V. While the reduction reaction here, the E cell, we are taking it from here. We need to have a point here. The E cell is negative 2.37 V. That is the E cell for that half reaction. But we know that E cell for the total reaction is equal to E cathode minus E anode. So in this case, our cathode is minus 2.37 V minus our anode is minus 0.44 V, which gives us, when we do our calculation, which gives us minus 1.93 V. Now the question is the reaction spontaneous? This is our E cell. So we will say that since E naught cell is negative, the forward reaction is non-spontaneous. So the forward reaction is non-spontaneous in this case, but the backward reaction can occur. But in this case we have a non-spontaneous reaction because the E cell is negative. So that is for A. A is a non-spontaneous reaction. It will not occur. What about B? Now for B, oxidation is here. So this one is oxidation. It is losing electrons. Oxidation, that is anode. This is reduction, that is cathode. And we can get the E cells from here. We know E cell for ion is minus 0.44 volts. E cell for cathode, now we are getting it from here, from the lead. E cell for cathode is 0.13 volts. So the E cell for the total reaction is given by E cathode minus E anode, which is minus 0.13 volts minus 0.44 volts. So if we do the math, we find that the E cell is 0.31 volts. So in the end, you will say that since E node cell is positive, the reaction is spontaneous. So that's how we check the spontaneity of this reaction. E cell must be positive. Let's look at another problem. What is the free energy, the delta G, for the following reaction? And when you calculate the delta G, state if the reaction is spontaneous or not. So for this reaction, we'll do the same thing. In this case, we are adding electrons to iodine to make iodine ion. So this one has iodine 0, this one has iodine -1. So this is reduction because you are adding electrons. So this is reduction, and we know reduction takes place at the cathode. Now here we are removing electrons from Br minus. So this is -1, this is 0 in terms of oxidation number. So this one is oxidation, which takes place at anode. Now you come here to determine the voltage of each half reaction. So if you look at the Br here, this is the reaction for that. So the voltage for oxidation 1.08 volts. Now the voltage for the iodine is plus 0.54 volts, and we know E cell is equal to E cathode minus E anode, which in this case is 0.54 V minus 1.08 V. And based on that, we get minus 0.54 V. So our E cell, E node cell is equal to minus 0.54 V. So just looking at the E cell, you can see that the E cell is negative, so the reaction is non-spontaneous. But that's not the question. The question is, you need to determine the delta G. So for that, delta G naught is given by negative N F E. So N is number of moles of electrons. So in that case, you need to count how many electrons are being transferred. So in this case, if you want to learn more about the electrons, first you need to get to the half reactions here. So in this half reaction, we see that we have 2 electrons being transferred here. In this half reaction, the same thing, 2 electrons being transferred. Because we have I2, the I2 is going to obtain 2 electrons to give 2I minus. 2Br is going to lose 2 electrons to give Br0. So in this case, our N is equal to 2. So this is minus 2 times the Faraday's constant, 96485 coulombs per mole. So this is minus 2 mole. Then times the voltage here, which is minus 0.54 joules per coulomb. We know that the voltage is given by joule per coulomb because it's energy per charge. So the mole here will cancel with mole. The coulomb here cancels with coulomb. And our result will be given in joules. So if we do the calculation, we find that the delta G of this reaction is 1.04204 joules. So I'll do the calculation again. So which is, when you have a big number of joules like that, you need to put it to kilojoules. So kilojoules per mole. So that is our delta G of this reaction. Now, if you look at the delta G is positive. So since delta G is positive, the reaction is non-spontaneous. We know that a spontaneous reaction has E0 that is positive and delta G that is negative. So in this case, we found two things. The E naught is negative, which means non-spontaneous. The delta G is positive, which means non-spontaneous. So that's how you solve these problems. Now let me look at the last problem. So draw a line notation for the following redox reaction. Now here you are given a redox reaction. If you want to draw a line notation, the left side must have oxidation, the right side must have reduction. You ignore the electrons. So this one becomes zinc solid, one line here, zinc plus aqueous. Sometimes you are given the molarity of that. Double line, copper, aqueous to copper solid. So in this case, this part is undergoing oxidation. This part is undergoing reduction. But this is the line diagram that we are looking for, or line notation. I guess this helps with the remaining questions on your video assignment. Thank you.